for better firefighter safety.
H2Know is a series of videos designed to teach the fundamentals of water flow. The series explores important topics and delivers fact-based results that are measurable and grounded in physics, not opinion. In video 3, we showed that the flow and pressure curve is identical when comparing a smoothbore to an equally rated fixed GPM fog nozzle. We proved that when you use the smoothbore flow formula to solve for D, you will discover which smoothbore size your fixed GPM fog nozzle is equivalent to. In this episode, we will use a selectable GPM fog nozzle to show that it is really the same as a collection of different sized smoothbore nozzles. A selectable GPM fog nozzle also follows the same smoothbore flow formula and reacts the same when pressure and flows change on the fireground. A selectable GPM nozzle has a selector ring that allows you to manually select an orifice size that will match a certain flow and pressure. It is very important to realize that the selected flow is only achieved when the nozzle is operating at the rated pressure of the nozzle. Each selection on the selector ring moves the baffle of the nozzle in or out, making the orifice bigger or smaller depending on the flow rating you are choosing. You are able to use the same smoothbore flow formula for each setting of the selector ring on a selectable GPM nozzle. Each choice on the selector ring is equivalent to its own smoothbore diameter. When we solve for D using the smoothbore equation, we can figure out the smoothbore diameter for each flow option on the selector ring at the nozzle's rated pressure. Although manually selecting a flow on the selectable GPM nozzle may seem like a benefit, it does present a new set of operational guidelines. As you can see, the selectable GPM nozzle reacts the same as fixed GPM nozzles. When your flow is cut in half, your nozzle pressure is reduced by 4 times. Many firefighters mistakenly believe that just because the selector ring is set for a flow, that they are getting that flow. One of the challenges of this type of nozzle can be the difficulty of coordinating with the pump operator. Here, we have a selectable GPM nozzle flowing 150 GPM at 100 psi. As an example, we will change the selector ring setting from 150 GPM to 60 GPM without communicating anything to the pump operator. As you can see, if the nozzle team changes to a lower flow setting while the pump operator is set up for high flow, the nozzle pressure increases above the 100 psi rating and the flow setting does not match the actual flow exiting the nozzle. Now let's see the results when we go from a low flow setting to a high flow setting without proper communication to the pump operator. Here, we have a selectable GPM nozzle flowing 60 GPM at 100 psi. As an example, we will change the selector ring setting from 60 GPM to 150 GPM without communicating anything to the pump operator. As you can see, if the nozzle team changes to a higher flow setting while the pump operator is set up for low flow, the nozzle pressure decreases by an extreme amount. The extreme drop in nozzle pressure results in loss of reach and impact force, and the nozzle team gets a false impression of their fire flow. The selectable GPM nozzle was an advancement in technology over the standard smoothbore and can be a solution for many fireground operations. However, it's important to realize that as proven with our field test experiments and standard hydraulics equations, the individual settings on a selectable GPM nozzle have the same flow and pressure results as individual smoothbore tips.